Thank you for the invitation. It's great to have this opportunity to present and discuss the work we've done over the past 10 years in natural meta-analysis. I'm a clinical academic working in Oxford. I'm a psychiatrist. And of course, my contribution to this series of webinars is more as a clinical researcher. So it's more the angle of how we ask the questions that are answered by the natural meta-analysis and how we can present the results in a way that can be used by clinicians in real-world clinical settings. So this is my disclosure. I'm supported by the National Institute for Health Research, and I also have received research and consultancy fees from some institution and also pharmacological industries. So the first thing is the real declaration of interest. So we are talking about evidence-based mental health or evidence-based medicine, but what I'm presenting is just one part, what we call research evidence, of the more complex scenario when we have to translate the knowledge into clinical decision making. So of course we are not presenting results as a cookbook medicine, but it is more about presenting the best available evidence that will be used to make a clinical judgment based also on the clinical state and circumstances, on patient preferences and values, and also the clinical expertise of the practitioner or the clinical staff. So just to be sure we are on the same page, we're talking about natural meta-analysis, and compared to the standard or pairwise meta-analysis, which lump together all the studies comparing treatment A versus B, so you have a pooled weighted estimate of A versus B, or A versus C, we have different trials. The problem is, if assuming this is all available evidence, of course, we don't have studies comparing B versus C. So what we do is to use a treatment which is in common, treatment A, to calculate the indirect comparison and indirect efficacy, or estimate treatment B versus treatment C. And this is natural meta-analysis. When we started 10 years ago, it was called multiple treatments meta-analysis or mixed treatment comparison meta-analysis, but they are basically identical, even though the methodology, the statistical methodology, has evolved dramatically over the past 10 years. I'd like to briefly show the huge advantage that natural meta-analysis have for clinicians, people who want to compare many treatments at the same time, because, for instance, with antidepressants, we have many drugs available on the market, is that we can use both direct and indirect evidence. In this example, which is from the 2008 publication, the natural meta-analysis we published in The Lancet about antidepressants, how we represent the total amount of evidence is crucial. So we wanted to represent the amount of patients for each drug, and the size of the node is proportional to the number of patients randomized to each of the antidepressants, the 12 antidepressants in this network. So for instance, fluoxetine, you can see, is a large node, which means a lot of patients randomized to fluoxetine, not so many to duloxetine. And the width of the line is proportional to the number of trials comparing two treatments. So we have a lot of treatments comparing sertraline with fluoxetine, only a few comparing duloxetine with fluoxetine, and none comparing reboxetine with mirtazapine. So if we want to compare reboxetine with mirtazapine directly, the answer is no evidence, but we can use fluoxetine as a common comparator to calculate the indirect evidence for reboxetine mirtazapine. And clinicians always think that this is the added value of natural meta-analysis. Personally, I think it's more important to use natural meta-analysis when we have the direct evidence. So we have data searching fluoxetine, but we can use the network to calculate the indirect evidence searching fluoxetine via a common comparator like venlafaxine, and we can have direct solid red and indirect dotted green lines to check the consistency of the information, how the information flows throughout the network. And the great thing is that you can do it with any closed loop within the network. Of course, it's important to have closed loop, otherwise we cannot check inconsistency. So the summary slide is the advantages, I think, for network meta-analysis are the comprehensive use of all available data, and direct and indirect. We can compare interventions which haven't been compared directly. We can improve precision of the estimate because we increase numbers, we increase power, and also we can rank treatments. I'll try to give you examples of all this and how we can apply this to clinical decision-making process. So this is the first natural meta-analysis we published in 2009. It was the first natural meta-analysis at that time, multiple treatments meta-analysis in psychiatry. And we wanted to ask a very specific question. I was finishing my residency in psychiatry at the time, and I remember asking the question, okay, I've decided to prescribe an antidepressant to my patients. We agreed about this. Which is, if any, the best treatment to give to this patient? And at that time, there were a plethora of standard pairwise meta-analysis saying treatment A is better than B, treatment B is better than F, treatment G is better than H, or there's no difference between C and J. So a lot of information, but not really clinically useful. So we tried to answer the question, lumping together in one natural meta-analysis all trials, all are randomized controlled trials comparing two active treatments, not placebo, because the question was, which is the antidepressant to prescribe to my patient for the acute treatment of major depression. And I wanted, in terms of visualization, at that time, it was important for me to report, to transparently report the situation of how sparse and scarce can be the information about antidepressants. I remember the editor of The Lancet was not very happy to have this table 1 in the paper, but I insisted, and in the end I managed to convince them, because it was crucial for me to show everybody how much information was available. So bupropion with 5 comparators, but duloxetine only 3, for fluoxetine all the other 11, and report the number of patients and all the data in terms of numbers we used to calculate the odds ratios. And the primary outcomes were efficacy in terms of response rate and acceptability, dropout rate, all at 8 weeks, which is the acute treatment. So we generated the network, as I said, with the representation of the amount of information available there. But this is the most important contribution, I think, of that natural meta-analysis, because I spent days and days trying to think, once I had the results, how can we help clinicians and patients having one place, which meant in one page, everything about what we try to answer. And as clinicians and patients, we want to know which is the most effective treatment, but also the most acceptable. So I ended up developing this league table, reporting data of comparative effectiveness between all the drugs. So these drugs are in alphabetical order. The bottom left is about efficacy, the top right is about dropout rate. And I wanted to show that I can have an estimate of all different comparators, so no blank cells. And I wanted to highlight the the comparisons which are statistically significant, hence the bold and highlighted figures. We were discussing before about the comparison between mirtazapine and reboxetine, and this is probably something at that time was not clear enough in the table, because it's very, very informative, but at the same time, you don't know which is the comparison which is using only indirect evidence like mirtazapine versus reboxetine, or the comparison like fluoxetine sertraline, which has also direct. So the estimate is called mixed estimate. So this is something we try to improve over the next few years in terms of reporting, but it was very important for me to have in one place all the information, so you can check that Mirtazapine is statistically significantly better than reboxetine in terms of response, but also if you look at side effects, acceptability, all-cause dropout, tends to favor mirtazapine, but it's not statistically significant. So you have a better understanding of the full picture. As I said, the other great advantage of natural meta-analysis is ranking treatments, and you can estimate the probability for each treatment to be in each position. So for this theoretical network of 4 treatments, you have the probability for A to be the first 25%, for B to be the first 50%, 25% for C, and 0 for D. And you can do this for all the different positions, second, third, and fourth position. And you can easily say that you can rank the treatment because B is 50% the first, C is 50% the second. If you look at A, it's 75% probability to be among the best 3 drugs, and D only 25%. So the third is A and the fourth is D. And because we rank the treatment, again, how can we represent this information to clinicians? There's a lot of discussion about how reliable is the information about ranking. At the end, I'll show an example of how misleading it can be. But assuming you're doing the right, you're using the right approach, we ended up with this idea. So this is from the same paper, The Lancet, 2009, and we had 12 antidepressants because this is the list of drugs we wanted to include in our presentation. And I want to have the probability on the y-axis, and on the x-axis, of course, we have the ranking. So it's not great, but this is first, second, third, fourth position until the 12th here. And we have for each drug a plot of the probability to be in each position for the 2 outcomes. So the dotted blue line is acceptability, and the solid red line is efficacy. So it's immediately clear to a clinician and also a patient that, for instance, paroxetine here is clearly not the best drug in terms of probability of responding and being acceptable, because it's more like a second-line treatment. If you look at other drugs like sertraline or, as I said, escitalopram here, we have also we have a completely different scenario, so they're quite good on both outcomes. And what it's interesting is to see that some drugs like citalopram have different profiles, more acceptable than efficacious, which is the opposite compared to venlafaxine, which is very effective but less acceptable. Or some drugs like reboxetine, just forget about. I mean, it's clear looking at this average data with all the limitation, but these can be an evidence-based guidance to help clinicians and patients decide which is the treatment to start. However, the problem is we tend to look at always which is the winner, and also these are probability to be the best in each position. So taking into account the uncertainty around the estimate is very important. And according to the protocol, we decided to consider the 4 best treatments. So the treatment with the highest probability to be among the most efficacious, the 4 most efficacious and the 4 most acceptable. And here you can see that in the end, we have this list of most efficacious and more acceptable, and 2 drugs were in the 2 lists. And this is why in the end, we said that these 2 drugs should consider the first-line treatment for depression. But we also said, and this message was captured by media a lot, but what was important for us was the bottom part of the list, because you can see that some of the drugs are in both lists. So it means that probably these are not a good start as a first-line treatment for depression. So this is a better way to inform clinical decision making, I think. Another example about acute mania, another paper we published in The Lancet in 2011, just to show that depending on the situation of how good and how big is the evidence base, of course, the results can be different in terms of strength and also interpretation. In this situation, so for acute mania, we use basically the same outcomes. So response after 3 weeks, and so efficacy, sorry, after 3 weeks, and dropout after 3 weeks. But because for acute mania, the outcome is usually measured as a continuous outcome, we didn't use response as the primary outcome. The situation is very similar, even worse, because each drug, especially the new ones, have very few comparators. And this is the shape or the geometry of the network, which is also crucial to understand. And this figure for me is important, not just to show that we don't have a lot of drugs of interventions with head-to-head comparisons, so not too many closed loops. But the other thing is, compared to the previous one, placebo here is clearly the reference. So how can we move the field forward and try to represent this in a, as I said, clinically interesting way? And this is the table for completeness of information, but this is the bit I want to show you. So we decided to use a standard forest plot using mixed evidence, so data from the NETRO meta-analysis. And because we had placebo, we wanted to have placebo as a reference and present the data about mean change, so the primary outcome for efficacy, and dropout rate compared to placebo all the time. And it was a nice visual representation of how big are the differences. So basically all the drugs are better than placebo. They are all on the left-hand side of the forest plot. But among them, there are clearly differences in terms of efficacy. And in terms of dropout, we expected basically no differences because all these patients are inpatients or placebo to be better, and actually we found that 3 drugs were better than placebo in terms of acceptability. So the shape of the network, the geometry, and also how we can report this information clearly to clinicians. But discussing with patients and clinicians, the feedback we had is it's too technical, how we can move forward. Again, try to simplify, but not to make it too simplistic. And this is what we came up with. So the hypothesis was a combination of this efficacy and acceptability. So we normalized, assuming that the best treatment was 100%, 50% efficacy, 50% acceptability. So we normalized everything to 100 and reported the drugs listed, ranked the drugs in descending order, considering the total amount of efficacy and acceptability as a percentage, but dividing using colors to show which is the contribution. So for instance, the more blue you have, the more efficacious the treatment is, the more orange you have, the more acceptable the treatment is. So for instance, if you look here at haloperidol and quetiapine, they have very similar overall scores, but you can see that haloperidol is more effective, than quetiapine, and vice versa, is very less tolerated, acceptable than quetiapine. So when we ranked treatment, we ended up with this figure because we wanted to present the results using ranking. So this is the ranking on the y-axis for efficacy from the 1st to the 14th. We had 14 drugs here, and on the x-axis we had acceptability, and we ranked the treatment depending on which was the ranking position in each of acceptability and efficacy outcomes. And you can see here that risperidone is second in both the two lists. Olanzapine is the first in terms of acceptability, but it's the third in terms of efficacy. Haloperidol is the first for efficacy, but only the 7th for acceptability, and so on. And we plotted these, and I think, again, the most important results are at the bottom left, because you can see that, as expected, these treatments are really poor performers. For the best performing, it's quite heterogeneous. And when we published this paper in The Lancet, we used these colors. And just to share some personal experience, when I was asked by the NICE guideline committee to present these results about the acute mania NETRO meta-analysis, I went and presented these results. And I remember when I showed this slide that people, actually the the chair of the meeting, said, "That's a very nice picture because it's like the rising sun. It's the dawn of a new era when we have clearly the the natural meta-analysis as a tool to inform clinical decision-making process." And I said, yes, thank you very much for the compliment, but actually this is a graphical representation of the Italian flag, because in 2011 it was 150th anniversary of Italy as a country, and I wanted to use colors to identify what could be a threshold. But so this is not the rising sun, it's just red, and this is absolutely subjective, because the problem at that time was that we were missing one key important information, which is, so ranking is important, but we also need to understand how big are the differences between the individual drugs. So what we did was to publish a paper using this cluster ranking in order to cluster together drugs that are similar, but also the difference between the drug is proportional for each outcome. So for dropout rate and efficacy, we have this representation, which is more, which is closer to the reality, and it's definitely more informative than the rising sun or the Italian flag, as you prefer. Okay. Yes, this is a paper we published in Evidence-Based Mental Health. It's free access, and it's a good way as a primer to have a better understanding of this kind of approaches we used. So another problem when we represent the data in a natural meta-analysis is to show how complex is the information from the trials, because at the beginning it was very easy, antidepressants, monotherapy, anti-manic monotherapies. But when we looked at the maintenance treatment for bipolar disorder, we had some nodes which were quite complicated, because we have 2 active treatments or an active treatment with placebo. So for this natural meta-analysis, according to the protocol, what we decided was to use data only for drugs or interventions that were connected, so only closed loops. Single standing nodes were not included in the analysis, and we wanted to represent this with this circle just to show which is the evidence set that we used. And when we presented the data, again, we introduced some degree of subjectivity, but we thought that quality or certainty of the information was a key element to judge this very difficult field in terms of quality of the evidence. So again, a priori, we said we want to rank or group the different treatments into categories. So at the top, we have the drugs with the best evidence, not just in terms of statistically significant results, but also in terms of quality. And we try to combine them. So for instance, lithium, you can see, is better than compared to placebo in terms of any mood episode, in terms of relapse of any mood episode, but also specifically manic episode, depressive episode, and overall acceptability, all-cause dropout rate. It is worse than placebo in terms of side effects, dropouts due to side effects. And if you can see this second tier of drugs, we have drugs that are not really better than placebo. For instance, lamotrigine is not better than placebo in reducing the risk of manic relapses, or for olanzapine, it's not good in terms of preventing depressive relapses and so on. But if you look at quetiapine, the profile of quetiapine is better than lithium, because it's the same as lithium, better any mood episode, specifically manic, depressive, better in terms of all-cause dropouts, and there's no difference in terms of the dropouts due to adverse events. So why did we decide to rank the treatment and group the treatment this way? Because we use this matrix, and it's clear the difference between the two. We use this matrix to show which is the contribution of each comparison to the overall estimate of the mixed evidence or the natural meta-analysis. And we found that there was one study about quetiapine and lithium and placebo, which was clearly biased by sponsorship bias. So we decided to downgrade the evidence and incorporate this downgrading into this final representation with using colors. Again, another way of visualizing different approaches and different conclusions. Another example is from the natural meta-analysis about antidepressants in kids, another network very sparse with only a few head-to-head comparisons, very few closed loops. So how reliable is the evidence is quite it's a big question mark. And at that time, what we did was to use the usual league tables, and we focused on one important outcome, which was suicide. And this is the published report of the table reported in the published paper. But what we did in the appendix, and we actually did the same in the acute mania, is to use the league table to show how is different when we have the direct evidence only compared to the mixed evidence, so combining direct and indirect, and also filling all the gaps. So league tables can be used also, and they are used now very often, to show which is the total result combining mixed evidence, direct and indirect, and only direct with all the gaps in the information. Network meta-analyses are becoming very trendy. We published this paper in the Lancet a few years, in the Annals of Internal Medicine a few years ago. But what is clear is not just that they are increasing, but also they are very, very influential because the references of natural meta-analysis are skyrocketing. So this helps me draw attention to the importance of the protocol, and we now tend to publish the protocol. And it is important to clearly set which are the outcomes, the analysis, the methods we follow. But I think it's also important to have this graphical representation, which is the tentative network. So the network, ideal network, if all the treatments are compared to each other. This protocol is for the network meta-analysis we published in the Lancet 2 years ago in 2018 about antidepressants, and this is slightly different from the 2009 because this time we wanted also to ask the question whether antidepressants are efficacious. So we included placebo in the network, as you can see here, and the number of drugs has increased because new drugs have been introduced on the market, and we also wanted to have some old drugs like tricyclics as reference. This is the paper, and it's important to also show readers which is in the Prisma diagram, which is the information and what is contributing to. Using colors, I think, helps a lot because it makes clear how things can be presented. And this is the real network. We started from the theoretical ideal network. And because we had, again, two primary outcomes, response rate and dropout rates, I wanted to have in one figure the two networks. And this is very informative, I think, because you can see that we have a lot of connections. Again, we have many, many patients randomized to placebo, but many, many head-to-head comparisons. And the second thing is that the shape, the geometry of the two networks is very similar. So our assumption, our hypothesis that we wanted to combine in the primary outcome both efficacy and acceptability, dropout rate, is reinforced because the same trials contributing, and so the same patients contributing to the efficacy outcomes are also contributing to the acceptability outcome. So to answer the question, are antidepressants better than placebo? We wanted to use the standard forest plot figure using NMA data. And I wanted also to give something to clinicians. So because efficacy and acceptability are opposite in terms of response rate compared to dropout rate, what I did was to invert, as you can see, the scale at the bottom on the x-axis. So we can always have on the right-hand side favor the drug, and on the left-hand side favor placebo for the two different outcomes, efficacy and acceptability, using colors. Blue favors the drug and orange favors placebo. gray, no difference. But I think it's a nice example of how you can show the data and how this can inform decision-making process. The other thing is, if you plot the two together, you can also have interesting results, because if we use, this is what we notice, if we combine all the studies and we use data from all the studies and we combine acceptability y-axis and efficacy x-axis, we have 22 is placebo, these are the 21 drugs, 16 is reboxetine because it's the least effective. You can see visually how this is clustered, so they are clearly better in terms of efficacy than placebo. They're not really different in terms of all-cause dropout. But it is nice because using the same graph, using the same anchor point as reboxetine, if we include only the head-to-head studies, excluding placebo, differences are much, much wider. So basically, if you include placebo in the network, all the differences shrink. And this is the figure we wanted to have in the Lancet to show, as I said, having 16 all in the same place, and of course 22 is placebo, is here only, not here, how these are can inform, again, clinicians and patients about what to do. Okay, just to finish with a caveat about how risky it is to do network meta-analysis. I said it's very popular, very trendy, but it's very easy to do mistakes also in very good journals and very good authors. So this is an example of a paper published in the BMJ in 2011 about treatment of generalized anxiety disorder. Even if the title doesn't mention network meta-analysis, it is a network meta-analysis with, as we can see, some closed loops, but I mean, placebo is the key player. And I was very, very impressed when I saw the results, because here the authors report the probability to be the best, to be ranked the first. And you can see that fluoxetine is clearly the best in terms of response, remission, only second to sertraline in terms of dropouts due to adverse events. But it's clearly the drug to go, the drug of choice, looking at these results. One means that there's only one study comparing reboxetine with placebo, and it's a 3-arm study comparing reboxetine with placebo and with venlafaxine. So it was easy to find. I couldn't resist the temptation to go and see the results. And this is the paper that was used in this network meta-analysis. And as you can see, this is a subgroup analysis of an existing trial, so with comorbid major depressive disorder and GAD. And 92 out of 368 patients were analyzed. And not only it's a subgroup, non-randomized, but also it's interesting to see that if you compare for the Hamilton anxiety, so for the anxiety outcome, if you compare fluoxetine, placebo, and venlafaxine, you see that in the end, venlafaxine has a better improvement of the symptoms compared to fluoxetine. So there's clearly a sort of inconsistency between the direct and indirect evidence, which is not mentioned in the paper, and also looking only at the first, probability to be the first, completely miss out the key issue, which is the uncertainty around the estimate and the uncertainty around the ranking. We explained all this in this paper we published 3 years ago in Evidence-Based Mental Health. Of course, we submitted to the BMJ, but they didn't want to review it. Okay, thank you very much. I'm here to take any questions.
Thank you very much, Andrea. So I think that one question that we have is, what do you think should be the highest priority for Cochrane to build into their reviews that include network meta-analysis?
So I think the Cochrane is doing a lot of network meta-analysis, and I think it's much, much better than years ago, the field, because I have to say that the best methodologists for network meta-analysis are directly involved or closely linked to the Cochrane community. So in terms of methodology, I think it's very strong. It's the best people. The problem is it's not just for natural meta-analysis, for Cochrane in general, because I think for natural meta-analysis, we need to be very focused and very clear about which is the question. And the problem with all the Cochrane reviews is they're too large, too big, and they end up not being very informative from a clinical point of view. So I don't think it's about the methodology, it's more about the utility and the vision and the use of natural meta-analysis. And the second thing is we need to move into living natural meta-analysis. So COVID is an example. There are many groups, Cochrane related, who are trying to do this huge endeavor, which is monitoring and updating every day or every other day, which is the available evidence, and then build natural meta-analysis day after day. And this is probably something that should be done on a larger scale and should be taken by policymakers and guideline developers, because this is the way to go.
Okay, thank you. And another one. How do we address the different time length of individual studies in network meta-analysis, or even graphically?
Sorry, how do we present?
Different time length of individual studies in the network meta-analysis, so the different durations, I think. So well, studies of different durations.
Sorry, it depends on the question, because for instance, we had usually we have acute, so short-term and long-term. So usually these are represented in different networks. So sometimes, of course, it depends on the protocol. If you want to take, as it happens very often with psychotherapy trials, the endpoint scores, so they can range 3 months, 12 months, 18, 24 months, which can make sense if you look at some outcomes, I think, like, for instance, suicidality. But if you look at efficacy, I mean, it's, how can I say, not less easy to justify, because I'm a clinician. So if I want to treat a patient acutely, it's completely different, the acute response to a treatment, to a sustained response, or to a relapse prevention treatment. So I would be careful, and time points really matter, and they have to be specified in the protocol.